crowd is smaller than we had feared. We might take that as an opportunity to, I think, maybe make this a little bit more custom, a little bit more specific. This is about running Docker running Drupal Cloud Native with Docker. Can I just ask everyone, put their hand up if they run Drupal web servers in production? All right, cool. Anyone here familiar with Docker? More, okay, good. How would you rate that confidence? You feel good, feel like there's a lot you got to learn? Average? Cool, all right, I got one thumb up, thank you. Okay, cool, so we might just tailor the focus a little bit for that. So yeah, Scott.
Okay, so what we'd like to do this morning is share our story about setting up our internal Drupal hosting platform, where we set out to run Drupal on AWS as a cloud-native application. And this process was not as effortless as we might have hoped. There were a number of challenges we had to overcome. We're going to share the lessons we learned and what those challenges were, and hopefully this will be helpful for you in future projects. Finally, we hope to convince you of the benefits of running Drupal Cloud Native and why we believe this is the way to run Drupal in production. Why is this? That's because running Drupal Cloud Native means it's more reliable, more secure, more scalable, and should be significantly less cost than a traditional hosting platform. It's a bit of extra effort up front, but we believe that that time invested will really pay off. Over to you, Mike.
All right. So let's start really quickly by just having a quick catch-up on the way, at least at Technocrat, the way we used to run Drupal, the way I think a lot of organizations run Drupal, which is with your traditional web servers. These are tin, possibly cloud servers, VPS servers. They are long-lived systems that you generally build by hand. You may have heard the analogy of pets versus cattle, where your traditional servers are more like your pets. You name them, you grow them, you care for them over time. And because of that relationship that you actually create with your own infrastructure, you think that that's a healthy environment. And of course, because we think of them as pets, we think that's a good thing. Everybody wants a pet. Probably a lot of people don't want cattle, and that's just a little bit morbid. I would rather think of this as a bit like Homer's 10-foot hoagie that he gets at the company picnic, that he collects, he loves, he cherishes, and the longer he keeps it, the worse it is for him. So if you haven't seen the episode, just really quickly, I have lost my mouse. There we go. I will just play this for you for just a moment.
Oh great, Dad's dead. Have you been eating that sandwich again?
Sandwich.
Jeez, we hardly made a dent in that 10-foot hoagie.
I'll give it a good hope.
We've been eating that thing for a week. I think the mayonnaise is starting to turn.
2 more feet and I can fit it in the fridge.
Homer, I found this behind the radiator. I really think you should throw it away.
Suggestion noted. Marge, I'd like to be alone with the sandwich for a moment.
Are you going to eat it?
Yes.
So I think that sums it up pretty nicely. You've got this thing that you think is really good for you, and actually it's making you sick, and it's going to ruin your weekends. So the traditional Drupal web server tends to accumulate undocumented change and potentially even unauthorized change. The scariest thing I can think of is a server that I've had running for 6, 12, 18 months that has been exploited and has been carrying that exploit around for far too long. They tend to be difficult to scale, they tend to be slow to provision and replace because they are built by hand, and they tend to be inconsistent because they are built by hand. Your staging and your production environment, especially over time, are going to have subtle differences. So that's traditional web servers, but Drupal...
So I think it's fair to say that Drupal loves traditional web servers. Out of the box, Drupal basically expects your web server to look and feel the same as it would have 10 years ago. And if you just take vanilla Drupal, it's not ready automatically to take advantage of the sort of cloud services and capabilities that are available to us today, just as it is. So getting it to the point where we can take advantage of that is a bit of a tricky process. One of the first challenges that we come up against is where are we going to store all our local files? So how are we going to handle the public and private file system that Drupal has if we're not going to store it on the local disk. And then if we're going to run multiple webheads, which we probably will be doing in production, then we'll be looking at even more things, more difficulties, which we'll talk about in a minute. Also, Drush expects to have SSH access to the environment, and this can complicate things. But before we go further on that, let's take a bit of a look about what a cloud-native environment looks like, and then we can start to think about how do we bring Drupal and the cloud together to work together nicely. Thanks, Mike.
So when we talk about cloud native, we talk about cloud servers and cloud services, which makes it really simple. Cloud servers are generally actually worse than your traditional Drupal web server. They're short-lived, they're unreliable, they are cheap, which is definitely a benefit. There's no SLA, there's no backups, it is the Wild West. If you haven't worked in production cloud environments, generally they tend to come separated into availability zones. Terminology might change between providers, but generally you've got a series of availability zones. An availability zone is a fault-tolerant data center, has redundant power cooling, good security. It is a professional environment, and an availability zone going offline is very, very rare. Inside of that availability zone, your server is not fault-tolerant, it is not highly available. If it dies because a disk drops, because the power supply fails, that is it. It will go with a moment's notice. If your cloud provider wants to run an update, they will possibly send you a notice telling you that your server is going to go offline. They may provide a way to move it to another physical instance, but sometimes it's just going to die. So when building for cloud native Drupal, we have to think about this restriction that can actually turn into a benefit, that our cloud servers are inherently unreliable. Second is cloud services. By taking advantage of the fact that most cloud providers, most public cloud providers, offer services that we would have to traditionally provision ourselves. The most common example is your Amazon RDS service, your managed SQL environment. That's probably the first really good example of a managed cloud service. There are others like Elasticache for managed Redis, S3 for distributed object storage. We will talk about those three today. But they give you, generally they're a little bit more expensive in pure infrastructure cost. A similar sized RDS instance will cost more than if you provisioned your own database server, but because you don't have to run that management layer, you're going to save a tremendous amount of time and money on that. So cloud servers and cloud services, by approaching that design, we gain access to a lot of native benefits. Simply by expecting our servers are going to die at a moment's notice and trying to move as much of our workload off into a managed cloud service, we can take advantage of auto-scaling, self-healing, and consistent environments because we are building by script now rather than building by hand. We can lower our cost because we can scale really easily. If you've got an e-commerce site, for example, you want to scale up before Christmas, you can size up your instances, and after Christmas you can size them down. You don't have to do this by hand, you can just do this by script. Easy rollback and greater security because you won't accumulate undocumented change, and you won't certainly accumulate unauthorized change.
Okay, so thinking about how we're going to get Drupal into the cloud. So as a starting point, you could say, all right, let's deploy Drupal on an EC2 instance, and yay, Drupal's in the cloud. But it's not going to work too well because you could lose your instance at any time, and you could lose all the persistent files that you want to store on that instance. So it's not going to be reliable. It's going to be even worse than running it on a traditional web server. At its core, cloud native Drupal means that the web server is temporary. If the web server is temporary, then the first big hurdle that we have to overcome is where are we going to store our persistent files, Drupal's public and private file system. If we're running on multiple webheads, then we run into a few other questions. How are we going to sync cache? How are we going to handle generated CSS and JS assets? And how are we going to spin up new servers quickly? Over to you, Mike.
So how? We've talked about distributed storage, we've talked about distributed cache, we've talked about scripted infrastructure. There are sort of these 5 areas that we think we need to cover off in order to run Drupal Cloud Native. Certainly we could go into a lot of depth with any one of these. We'll do a talk about any one of these. So we will gloss a bit. Again, at the end, if you want to come up and ask us questions, please do so. We love talking about this stuff. So S3 is our distributed object store for our public-private file system. Dynamic variables enables us to inject configuration into our Drupal application at runtime, so we can run the exact same code base for staging, prod, dev environments, and only modify it by changing its settings. And that gives us greater consistency as we move towards deployment. We use a distributed cache. We use Redis, you can use others, to effectively remove load from our SQL server and to run multiple webheads reliably. We use Terraform for our scripted infrastructure. There's a lot of tools for this: Terraform, Chef, Puppet, Ansible, CloudFormation. You could pretty much roll whatever you like. Terraform is very good because it gives you both the macro and micro level control over your infrastructure. You can use it to provision whole AWS environments down to the granularity of saying, when you run a server, I want you to run these commands in that server. So it gives you a lot of power in that regard. And finally, Docker and containerization. We did not do this in our first instance of Cloud Native Drupal. We ran it directly on the server. It isn't necessary, you don't have to do it, but there's a lot of ancillary benefits in running Drupal in Docker that we'll talk about. So to start with, I'm going to hand over to Scott, who's going to tell us about S3, dynamic variables, and distributed cache.
Okay, so looking at this first issue of persistent file storage and how we would handle this. So large hosting providers handle this using clustered file systems. And what this means is you can mount the files directory as a shared drive, and this solves the issue for you. But running a clustered file system is expensive, and it also requires a significant amount of maintenance. You basically need a cluster engineer to manage this for you, and unless you're running you have your own DevOps team available, this isn't really a viable solution for most of us. So in our first project where we were using this environment, what we used for a solution was AWS S3. So if you're familiar with S3, it's a key value store where the key is the path to an object and the value is the object itself. It's ideally suited for Drupal file storage because you can store an unlimited number of files, and so it's easily scalable. It's fairly easy to integrate into Drupal using a module called S3FS. And it has an added benefit that if you were working on a project with a really large collection of assets, images for example, then you can, by having all those assets stored externally in S3, then developing locally, you don't have to download them all onto your computer. So it means you're working on a website, your local developer doesn't need to store 40 gigs of images of bed sheets onto their local environment, which is a bonus. So looking at configuration for S3FS, there's a few key things to look at. One is we need access credentials. We need to have the right permissions to access the S3 service. We also need to look at bucket names. So in S3, we have collections of assets stored in different buckets. So at the very least, we probably want different buckets per environment, so production, staging, and possibly local development. Another configuration choice you can make in setting up this module is that you can configure it to have per field storage, so fields being within entities, or you can configure it to replace the entire public or private file system with S3. And I'll speak more about that in just a minute. So if we've got this kind of configuration in the module, it's pretty clear that we're going to need to vary this configuration per environment. So there's a couple of ways to do this, but one possible way is there's a module called config split. And what this lets us do is that we can create a split per environment. So you could have one split for staging, another one for local, and then your default configuration is your production settings. And then in your settings.php file, you can activate a specific split depending on what environment you're currently developing in. And that lets you have different buckets activated for different development environments and different access credentials configured. So as I mentioned, there's two configuration options as far as how you're storing your Drupal assets in S3. So one is per field configuration. And what this means is that you're taking each individual field which exists within a Drupal entity, and you're saying the storage location of this field is now S3 instead of the public file system, which would normally be on the disk. We started out with that configuration, but found that it's problematic if you're going to move to multiple webheads. It's slightly simpler to configure, but there's a lot of benefits in going with the second option, and the second option is replacing the entire public or private, if you need it, file system with S3. And what happens in that case is that within the Drupal website and Drupal environment, anywhere where we're using the URLs with the public prefix, they're now automatically behind the scenes redirected to S3. What that also means is that if we're putting the entire public file system into S3, then we're also putting generated CSS and JS assets into S3. And so there's a couple of additional configuration steps to make sure that that works correctly. One thing we need to do is to configure the web server, so Nginx or Apache, to proxy any requests that have a particular prefix, which these are the default ones that S3FS uses, so CSS and JS prefixes. So any URLs with that prefix get proxied to the S3 bucket to load them externally. And we need to do this because our web server and our HTML expects JavaScript to be loaded locally, otherwise we run into security issues. Also, CSS often uses relative paths, and so if we don't have a relative path for loading our CSS, then we're going to run into issues with the CSS files. Another thing that we have to change is that by default the twig cache is located in the public file system, and it's not practical to have that sitting in S3. So what you can actually do is configure the twig cache to be moved outside the public file system and just to somewhere else outside your document root. And even if we're running multiple web heads, it's okay to move your twig cache outside the document root, even though that means you're going to have copies of it on each web server. It's not an issue for performance, and when a request hits that particular server, if that cache isn't populated yet, it'll be regenerated. So dynamic variables. Dynamic variables are the knot that ties all this together. So Drupal needs to know where it is and how it should connect to the infrastructure that's around it. And so what we have is the ability to pass environment-specific variables from our Docker Compose file into our containers, and then our deployment script can write a .env file into the project root. That file can then be read into memory via the PHP FPM process, and then finally Drupal can load the settings.php file and access those variables via a getEnv function. So for our caching solution, we used Redis, and AWS provides an Elasticache service which allows you to run Redis, and there were a couple of reasons that we went with this option. First of all, having all your caching moved out of the SQL database, which is where it is by default, and into an external caching provider means that we're taking a lot of load off the database and moving it instead to the caching service. And so that can significantly reduce bottlenecks that you would have had with a lot of traffic and requests going to your database where they no longer need to. Particularly if you're running in a high traffic environment and you're starting to run a number of web servers. You don't want to have 10 web servers, for example, and then all getting bottlenecked by requests to one SQL database. What this also lets you do is you can actually have an Elasticache cluster, and so then all your web servers can connect to your Elasticache cluster, and then you've got like a scalable caching service alongside a scalable web server layer. Setting it up is easy. There's a Redis module which you can just plug into Drupal. You tell it how to connect to Redis. You tell it that we're using Redis for the caching backend instead of the database, and you load the services.yaml file that comes with the Redis module, and this lets you move your lock management and your flood protection management into Redis as well instead of in the database where it is by default. And now here's Mike to tell us more about infrastructure.
So I mentioned before we run Terraform to run our scripted infrastructure. If you're a dev, this stuff might look a little bit weird and intimidating, but actually it's a lot easier than dev. I tend to hold a reverence for Drupal devs because you guys get to do the harder stuff, and this is really pretty straightforward. On the screen here on the left, you've got an example of a Terraform resource definition for an AWS load balancer. It's going to look and feel a lot like JSON or YAML. It's the HashiCorp configuration language. HashiCorp are the guys that make Vagrant, which probably everyone is familiar with. Terraform is it will take these scripts that declare infrastructure. It will create a plan to run and build that infrastructure on a variety of different environments, and from there it will go ahead and deploy for you. If it identifies changes in the live infrastructure that aren't reflected in its scripts, it will remove them. So that's a really, really good way to get rid of undocumented change in your running environments. The syntax itself is really straightforward. You can see here we've got the load balancer definition. We can define a listener in the middle simply by saying the instance is listening on port 8080. The load balancer is going to listen on port 80. We can pull in outputs and variables from other Terraform resources. So we could say, right, we're going to create a security group called sgdnz public. I want you to get the ID from that. I want you to use these subnet IDs. So we can create really scalable, really dynamic infrastructure by doing this. when we run Terraform for our stacks, we create what's called Terraform modules, which are basically grouped resources that can be reused in multiple places. So we have a module for load balancers, we have a module for RDS, a module for Elasticache, and we can pull those modules in and modify them subtly by changing the variables that we inject into them. So for example, we can use the exact same module for staging and production with subtle differences such as passwords and stuff like that, and we end up with the same infrastructure. And again, that just breeds that consistency. As we move from dev to staging to prod, we minimize the risk that something's different in one of those environments that causes a problem or stops a problem from being identified before it's too late. Just like Terraform, Docker uses this declarative syntax. Obviously it's different, but it's the same sort of concept. It's not development, it's simply saying, I want you to, this is the result I expect, I want you to take these steps to come to it. So Docker, let's just take a look on the right here. This is an example Docker file, simplest way to explain it. This is a series of steps that we want Docker to take in building a Varnish image. When we launch that image, we get the container, and the container runs Varnish for us. Very simply, from an Alpine Linux image, set these environment variables, copy these files across, run these commands, expose a port, and then when you execute as a container, run this command. It's that straightforward. If we wanted to add another component in here, we simply add a line to the run command and rebuild the image. Docker images can be versioned, so we can very easily say, right, well, production's going to run version 1 of this Varnish container, and staging's going to run version 1.1, and we'll test that out. And once we're confident that it works, it's just a flag change in production to push that change up. Docker images and containers are very portable, they're very consistent, they're very fast to deploy and roll back, and there's that separation of concerns. We can write a container for Nginx, we can write a container for FPM, we can modify one without a lot of fear that we're going to trip over the other and cause problems. We bind all that together with a utility called Docker Compose. It's a very straightforward utility that reads a YAML file that defines the relationship between containers and defines how containers should execute the images that they're linked to. I mentioned before, actually I don't know if I might have skipped it, I mentioned it in rehearsal. We use a continuous integration system to build a data-only Docker container, which is basically a Docker container or a Docker image that executes and then just exits with a status code 0, but it leaves behind this volume that can be mapped into other containers and that those containers share. So if you have a look at this compose YAML file, we declare a container called content. This is our client site, pre-packaged and built and ready to deploy by our CI system. It maps a volume /te/site. That's our Drupal site. That container will exit, and then the volume will be available to the Nginx, FPM, and Drush images, and they'll share that. Obviously, if you're running Drupal in production, none of this should be writable, so a shared file system isn't necessarily the best thing, but for the sake of example, all of these systems, all of these containers share this file system. You can see here that we define an Nginx and an FPM container. We define how they execute, so for example, the ports that they run. And for FPM, we define that .env file that pulls in the dynamic variables. So all we have to do when we want to change staging to production, we change that .env file. That's the only thing that we really have to modify in each of those environments. We could run a different version of the container if we wanted to, but generally speaking, it's the .env file that contains the definition of that environment. And finally, there's Drush. Getting Drush to run in Docker was the hardest component of all of this for me. It does not lend itself to Docker very well. There are some examples out there of running Drush in Docker. The problem with it is that OpenSSH is not supposed to be run in Docker containers. It's a bit of an anti-pattern for Docker. The idea is that once you launch your container, that's it, you leave it alone. If you want to change your container, then you change the image, and then you republish it, and then you update your image tag. So this is a little bit weird for Docker. I'm happy to say that in a couple of weeks, once I finish writing the documentation, we are going to open source that Drush container. I've spent a couple of hundred hours on it, and I feel like it's enterprise ready, and I'd be really excited to share it. So if you want to have a copy of that, if you want to have a look at that, come up and see me after the talk, and I can hook you up. So that's it. That's how we run Drupal in Docker, Cloud Native in AWS. The results are really, it was a lot of effort in doing this. It's sort of been a bit of a 6-month story, but the results have made it really, really worthwhile. Just the S3 file system alone saves us a tremendous amount of money. S3 storage is highly available, very, very resilient, and extremely cheap. It's 2.5 cents per gig. That is a 1%. That is 1% of what you will pay for file storage with certain large Drupal hosting companies. So even if you're hosting with another provider, using S3, most of those providers are in AWS, so latency isn't really an issue. If you're hosting with another provider, moving your public and private file storage into S3 could save you a tremendous amount of money every month just doing that without doing the rest of this. Docker, as we mentioned, deploys really, really fast. It's really consistent. We've basically eliminated the issues of, well, it works in staging, why doesn't it work in production? The Elastic File Service, this isn't a result, this is a learning that we've got. The Elastic File Service is a relatively new tool from AWS. It's a cloud service that provides that distributed cluster that we mentioned earlier is cost prohibitive to run unless you've got your own DevOps team. We haven't run that in production yet. We've got that running in a proof of concept system. It's actually very powerful. It looks very good. It might be worth looking at as an alternative to S3 if that suits. We've improved security, but more than anything else, we've, especially by adapting cloud services, we've removed a lot of overhead in managing Redis, managing SQL Server, managing distributed storage that we otherwise would have had to concern ourselves with. So that gives our team the ability to just focus on writing Drupal. And I think that's the most valuable thing that we've gotten out of all of this. So there you go, that's us. This is Scott, I'm Mike. Thanks very much. If anyone has any questions, please raise your hand. Otherwise, come and see us afterwards. Question? No questions?
Not a question, like a comment. We ended up using EFS, and we did find it to be, very, very usable. Because we're using Drupal and the S3 module is still only in the alpha version, so we said now rather stick with something that looks like applying file system, and works well.
Yeah, good. It's probably worth mentioning, EFS is 3 times as expensive as S3, but that's still a tremendous amount cheaper than just about any alternative. As I mentioned, yeah, it works really well in our prototype environment. One of the things that you lose with S3FS is rsync, because the S3FS module doesn't really support that. There's just as easy a way to sync files between environments using the AWS CLI, but moving to EFS gives us rsync back, which has been helpful. Thank you.
Can you expand on this Docker page for Drush?
Yes.
Struggling to understand. The Drush needs access to the code base to figure out how to interact with Drupal, and how this can be separated in a separate container.
I'll come back to your question in a second. So, just scanning back really quickly, the YAML file. I started this project with very little or almost no Drupal experience whatsoever, so I had to learn all this stuff as I went along. The key is in that shared file system. So the Drush container, if you have a look, you've got volumes from content. Content is the container that runs the site, that contains the site.
So the code base is on this volume?
Yeah, on that volume. So they both see it, it's shared. If one of them changes it, the other one sees it. Part of the issue, one of the things that I really dislike about a general Drush practice is that everyone shares one user. And that sort of makes things very difficult for auditing. If you're running anything government, that's very, very frowned upon. But sharing users across those containers is bad. So what I've done with that Drush container is that it runs SSH as root, but it maps in public keys from an S3 bucket. You could do it from just about anywhere. And then you can see that volumes line, Docker authorized keys, that's all of our users. So if I add a public key into this volume, when Drush mounts, it will pull that key in, read the file name as the username, and then when the user SSHs in with their private key, it logs them in as their own user, and then they can then access that. The .env file that is mapped in the Drush container is the same one that's mapped in FPM, so it's the same settings running in each container. So if you run Drush status in the Drush container, it pulls all of those settings, all of those dynamic settings from its environment variables. Come and see me afterwards, I'll show you. Sorry, you had a question?
I just want to comment that EFS is also not in all AZs yet.
It's not what, sorry?
It's not in all the Amazon AZs.
No.
It's also very version dependent in some AZs.
Oh, does it differ?
Yes, very
Okay.
much so between Sydney and Singapore.
Okay, all right. Good to know. Good to know before we put that in production. Thank you.
And I've got a site of production in Singapore and they're locked up with it.
Okay, all right. Good. Anything else?
Piling on the FS.
Okay, go for it.
So we were running EFS in production for our Kubernetes cluster.
Yep.
And EFS, we didn't realise when we first implemented it that it has the concept of burst credits, kind of like your T2 instance classes. So the more throughput or the more file transfers you're making to the remote file system, your burst credit slowly drops down and down. And unless you have a large enough file, like I think it's 10 gig, on your volume, it never recovers these credits. So we had an instance where we did had a site in production for months and then all of a sudden just stopped working because we couldn't read and write from that volume. So,
Did you open a ticket? Did they say that that's a bug, or is that?
We'll replenish your ticket, your credits this once.
Oh, right.
But this is how you fix it, and that's your last chance.
Wow. Okay. How do you fix it?
We put a dummy in, 10 gig of dummy data.
Right.
Yeah, it costs 30 cents a month, but
Yeah.
we can.
That's how they make their money. Do that for 100,000 customers, and there you go.
Yeah.
Right.
Yeah.
All right. Good. Thank you. Cool. All right. Thanks, everyone. Good. All right. I'm gonna unplug that now.